FRQ 2000, problem number 3 by Maggie Tran. So this is a Taylor series problem about x equals 5, and we're given that f of n of 5 equals negative 1 to the n times n factorial over 2n times n plus 2, and f of 5 equals 1/2. So the first problem A, write the third degree Taylor polynomial for 5 about x equals 5. So I wrote out the information that we're given to help us find the Taylor polynomial, and it's asking for the third degree, so technically we need 4 terms. And what helps for me is that I write it all out, the skeleton of the Taylor polynomial, and then I find the coefficients and whatnot to plug into our Taylor polynomial. A common mistake students usually make is confusing the difference between terms and degrees. So our first term we know it's given is 1/2, and then to find f prime of 5, we'll just plug in 1 because that's the first degree into f of n of 5, and we should get negative 1 over 6, and then we keep the x minus 5 the same. And then to find f double prime of 5, we plug in 2, the second degree, into f of n of 5, and we should come out with a positive number, so that would give us positive 1 over 8. And then to find f triple prime of 5, we just plug in 3 into our f of n of 5, so we have negative 1 times 6 over 2 to the power of 3 times 5, which equals negative 3 over 20. So we'll put that into our Taylor polynomial equation. And if you want, you can simplify further. That's what I did. So I have 1/2 minus 1/6 times x minus 5 plus 1 over 16 times x minus 5 squared minus 1 over 40 times x minus 5 to the power of 3. And that's our Taylor polynomial for the third degree. So you can get up to 3 points for this problem, and you get -1 for each error or missing term, or for improper use of extra terms, or equality, or using the wrong sign. So problem B, find the radius of convergence of the Taylor series for f about x equals 5. So I'm going to write what we're given again, which is f to the n of 5 equals negative 1 to the n times n factorial, sorry I wrote the wrong thing, over 2 to the n times n plus 2. So my way of solving this is that we have to know the Taylor series, which is f to the n of x times x minus a to the n over n factorial. And then using that, we can plug in f to the n of 5 into f to the n of x. So we'll plug in negative 1 to the n times n factorial over 2 to the n times n plus 2. And then we will add in x minus 5 to the n over n factorial. And the n factorials will cancel out, and then 2 to the n times n plus 2 will move to the denominator. And then we're left with negative 1 to the n times x minus 5 to the n over 2n times n plus 2. Now we're going to use the ratio test to find our radius of convergence. So we have limit as n approaches infinity of negative 1 to the power of n plus 1 times x minus 5 to the n plus 1 over 2 to the n plus 1 times n plus 3 times 2 to the n times n plus 2 over negative 1 to the n times x minus 5 to the n. And then we can cancel out some of our terms, and then we'll be left with limit as n approaches infinity of negative 1 times x minus 5 times n plus 2 over 2 times n plus 3. And then I simplified it even further, so we have 1/2 times n plus 2 over n plus 3 times the absolute value of x minus 5 less than 1. And then we take our limit as n approaches infinity, and then n plus 2 over n plus 3 will just approach 1. And then we divide both sides by 1/2, and then we have x minus 5 is less than 2, so our radius of convergence is equal to 2. So you can get up to 4 points for this problem, so you get 1 point for the general term, 1 point for setting up the ratio test, 1 point for computing the limit, and 1 point for applying ratio test to get the radius of convergence. And then our last problem C, Show that the 6th degree Taylor polynomial for f about x equals 5 approximates f of 6 with error less than 1 over 1000. So using our form of f of x minus t sub n of x equal to r sub n of x absolute value less than or equal to m over n plus 1 factorial times x minus a to the n plus 1. So it's asking for f of 6 with error less than 1 over 1000. So we have f of 6 minus p sub 6 of 6 in absolute value bars less than or equal to 1 over 2 to the 7th times 7 plus 2. And I got 7 because it's n plus 1 factorial, meaning that we have to go up a degree. And then I got 2 to the 7 times 7 plus 2 from our original equation. So I plugged in 2 to the n times n plus 2 into the denominator. And if you plug it into your calculator, you should get 1 over 1152, which is less than 1 over 1000. So basically when you do error, you usually just go up a degree. So my explanation is abbreviated, but it's alternating series with absolute value of terms decreasing to 0. So for this problem, you can get up to 2 points, and you get 1 point for showing the error bound is less than 1 over 1000, and the other point is referring to an alternating series and indicates that the error bound is found from the next term. I hope you found this video somewhat helpful, so thanks for watching!